Okay, I'm going to run through some problems to review exponents and radicals. So the first objective is fluently apply the rules of exponents to simplify expressions involving integer exponents. Remember that integer exponents would be things like, 2 to the negative 2, the negative 4, 3 to the 4th, etc. So for number 1, it gives us a bunch of equations and asks us if they are true. Is 2 to the negative 2 equal to negative 4? No, it is not. Is 2 to the negative 2 equal to 2 to the 1/2? No, it is not. Is 2 to the negative 2 equal to 1/2? Nope. Is 2 to the negative 2 equal to 1/4? Yes, it is. That's what 2 to the negative 2 means. It means 1 over 2 squared. So none of the rest of these are 1 over 2 squared. That's the square root of 2. Certainly not the same as 1/4. This doesn't make any sense. That definitely doesn't make sense, but it's very tempting to do. The next few equations are a little more complicated. X to the negative 2y squared over z to the negative 3. Does it equal y squared z cubed over x squared? Yes, it does. The z to the negative 3 can move up into the numerator, become z cubed, and the x to the negative 2 can move down and become x squared. The y squared won't move because it had a positive exponent at the beginning. The next one is x to the negative 2y squared divided by z to the negative 3. Is that equal to y squared over x squared, all divided by 1 over z cubed? The answer is yes, it is. X to the negative 2 is the same as 1 over x squared, so 1 over x squared times y squared is that. And this is 1 over z cubed, so we could rewrite it that way. Probably wouldn't choose to rewrite it this way. I'd probably choose to write it this way because it's a little bit more simpler, but this is definitely correct. Next one asks, is 4/5 to the negative 2 equal to 25/16? And the answer is yes, it is, because 4/5 to the negative 2 is equal to 5/4 squared, and that is just 25/16. Finally, it says, is 3x to the 4th squared equal to 3 to the 8th x to the 8th? And the answer is no, it's not. This 3 is not raised to the 4th power. It's just there. So it should be equal to 3 squared times x to the 8th, but not 3 to the 8th x to the 8th. So that was number 1. Moving on to number 2. We've got 21b divided by 7b to the negative 5 times 6b to the 5th. So we'll leave the numerator as 21b, but in the denominator, this is all multiplied. So b to the negative 5 times b to the 5 is just b to the 0. But that's just 1. So anyways, 7 times 6 is 42. And then I have b to the 0, which is 1. So this should just be 21b over 42, which is the same as 1/2 b, or b over 2. Number 3 has 3xy to the 4th times 2x to the 6th y squared, all to the negative 1, all divided by 9x to the 4th y. I think we'd like to make this exponent positive, so this should just become 3xy to the 4th divided by 9x to the 4th y, so all that stuff stays the same. But then I'm going to multiply this by 2x to the 6th y squared. Since that entire parentheses is raised to the negative 1 power, I can just move it to the denominator and give it a positive 1 power, but I don't need to write positive 1 there. Now I'm just going to simplify. So this is 3xy to the 4th. Down here I've got 9x to the 4th y, and then times 2x to the 6th y squared. So I didn't really do any simplification there, but 3xy to the 4th divided by, so 9 times 2 is 18. Then I have x to the 10th, because that's x to the 4th plus x to the 6th, and y cubed, that's y times y squared. Now 3 over 18 is 1 over 6, so I can write it as x y to the 4th over 6x to the 10th y cubed. And since I have 10x's being multiplied here and 1 up top, I should end up with 9 in the denominator. And if I divide 3 of the y's, I should have 1 y left. So that should be y divided by 6x to the 9th. Okay, so these are a couple problems involving integer exponents.